Today's lesson is about linearization. Okay, let's get started. So look at this graph here, and I'm going to draw the tangent line at this point, for example. Okay, now look at these vertical lines. If I draw the vertical line here, the difference between the y value of tangent line and the function is big, and the tangent line wouldn't be a good representative of function when we are far from the point A. Let's get closer. For example, here. See the gap between the function and the red line, which is the tangent line, is getting smaller. Now imagine you are extremely close to A, like you are 0.01 away from A. So in that case, the difference between the y value of tangent line and, for example, look at here. Oh, my line is not like very vertical. So imagine this vertical line here. Since this vertical line is very close to A, the gap between the function and the tangent line is extremely small. This is why when we are very, very close to A, the tangent line can represent the function very well. So what is the benefit of replacing a function with a tangent line? So functions are often, complex and are difficult to get the y value of. But tangent line is a linear, so it's very easy to deal with. So let me give you an example. For example, f of x equals x cubed plus 3x squared minus 5x plus 7. And we are going to find what is f of 1.01. And you do not have calculator in this question. So you want to see how big the y value is, right? So one way is just to insert 1.01 into x, but 1.01 to the power of 3 or 2 wouldn't be easy to calculate. So this is why we are going to replace f of x with the tangent line at 1. Why 1? Because function behaves very good at 1, so we can find the y value at 1. And 1.01 is very, very close to 1. So this is why we need to write the equation of tangent line at the point with the coordinates of 1. And once you plug in 1 into the original function, it's going to be 1 plus 3, 4. 11 minus 5 is 6. For getting slope, you need to differentiate. 3x squared plus 6x minus 5. Therefore, f prime at 1, which is slope of tangent line, is going to be 4. So therefore, by having slope and point, we are able to write the equation of tangent line in the slope point form, which is y minus y1 equals mx minus x1. So 4x minus 4 plus 6 is plus 2. Therefore, for getting the y value, instead of inserting that complicated like number 1.01 into f of x, we insert it into y equals 4x plus 2, which is supposed to represent function very well. So it means y becomes 4 times 1.01 plus 2, which becomes 4.04 plus 2. That comes to 6.04. So this is the concept of linearization. It means instead of dealing with a complex function at a complex point, you simply work with the tangent line. So in the next page, I'm going to give you the formula of linearization in a very organized way. Again, suppose that this is the function, and this is a. So we are going to write the equation of tangent line at a in general. So this point A has the coordinates of a and f of a. Also, the slope of tangent line is going to be f prime at a. Therefore, the equation of tangent line is y minus y equals mx minus a. So I'm going to move f of a to the right side of the equation. Therefore, we will have this popular formula of linearization. So we are done with the formula. However, we'd rather to replace y by L of x, emphasizing that this is linearization of f of x. There we go. So now I'm going to give you an example to see how it works. Suppose that your f of x equals x squared minus 4 over x, and we are looking for f of 1.01 again. So a is 1, the point very close to 1.01. That function behaves, normally, because plugging 1 into f, like it doesn't, cause us a problem, right? So, and x is the exact thing that we are looking for. Therefore, putting these numbers into the formula, you will have L of 1.01 equals f of 1 plus f prime at 1, 1.01 minus 1. F of 1, so it's simple, just plug in 1 into f of x, so it becomes 1 minus 4, which is negative 3. We need to take the derivative. I'm going to do it here. So f prime x is going to be 2x plus 4 over x squared. Therefore, f prime at 1 is 6 times 0.01. Therefore, it's going to be negative 3 plus 0.06, which comes to negative 2.94. this is the answer by using linearization as a method. Of course, we have a little bit of error. And how am I supposed to get the error? If you want to get the error, you use your calculator and you plug in x 1.01 to see how different would be that number from the number that we got from linearization method. So I'm going to give you another example. Suppose that we are looking for square root of 85. So obviously the function that we are dealing with here is square root of x. Also, x is the exact value and a is the closest number to 85, which has a whole number as a square root or is a perfect square. I believe 81 is the closest one. You can choose 64, but since 64 is not close enough to 85, the margin of error would be great and it's not good. So let's apply the linearization formula here. Lx equals f of a plus f prime of a x minus a. So L of 85 equals f of 81, f prime 81, 85 minus 81. So f of 81, square root of 81 is 9. I need the derivative, so I'm going to take the derivative here. Everyone knows that derivative of square root of x is 1 over 2 square root of x. So once you plug in x81, it's going to be 1 over 18. And 85 minus 81 is 4. So simplifying by 2 brings us to 2 over 9. So it means the answer is 9 and 2/9. And that's wonderful, because now you learned actually that how to find the square root of the functions without calculator, and that's very accurate. And the last example of today, I'm going to get the value of sine 28 degrees. X obviously is 28 degrees. So A, the closest number to 28 degrees that we know the value of sine at that point is 30 degrees, because we know that sine 30 degrees is 1/2. And our function obviously is sine x. Let's apply linearization. So L 28 degrees equals f of 30 degrees, f prime 30 degrees, and x minus 30 degrees. F of 30 degrees means sine 30 degrees, which is 1/2. Derivative of sine is cosine. So f prime at 30 degrees is cos 30 degrees, which is square root of 3 over 2 times negative 2 degrees. So the problem here is that 2 degrees is not a number, and you cannot operate and combine it with other numbers. In order to be able to combine 2 degrees with the other numbers and get a final answer, you need to change degree to radian, because radian is a real number, not the degrees. So therefore, and in order to change an angle from degree to radian, all you need to do is multiplying it by pi over 180. So I'm going to write 2 times pi over 180. So it becomes pi over 90. Therefore, it's going to be 1/2 plus, I'm going to write it as minus because the negative here makes it negative. So negative square root of 3 pi, and 2 times 90 is 180. Yeah, this is the value of sine 28 degrees approximately by applying linearization method.